So in the last video we discussed about projectile on an inclined plane. This was the page which I used. So let me write all those important formulas over here. We grab all this. The first important formula was this time of flight. Let me write this. Time of t equals to 2v naught sine alpha upon g cos theta. This theta was angle of the inclined plane and alpha was the angle of projection, and we projected the body up the incline, right? And half of it was time of ascent and time of descent. Then we found what? Y max. We found this Y max, and Y max was this. Maximum height from the inclined plane. Maximum height from the inclined plane, that is V naught square alpha upon 2g cos theta. And then we found the range also. The formula of range was this. It's very complicated, but this was the formula of range. Let us have all these things. So the formula of range was that was equal to V naught square sine 2 alpha, that is this, g cos theta minus 2 V naught square sine theta sine square alpha upon g cos square theta. That was range. And in all this formula you can see that if you put theta tending to 0, then all this formula will turn into the formula for the projectile on a plane surface. If I work theta equal to 0, this will be 2 V naught sine alpha by g, which is time of flight for a projectile on an inclined plane. Projectile on a plane surface. Here what do you have? Theta is 0 for projectile on a plane surface. This inclined plane will convert into a plane surface for theta equal to 0. So time of flight will be 2 V naught sine alpha by g, and maximum height will give you 2 V naught square sine square alpha by 2g. And range also, when theta goes to 0, this part vanishes, and you have range equals to V naught square sine 2 alpha by g. Getting your point? Now there is one more case over here. Suppose instead of having projectile like this, if I project the body down the incline, what will happen in that case? If I project the body down the incline, then in that case you don't have to work on separate formula. Suppose we have this case and somebody says I am projecting the body like this. This body is going like this. Here I projected like this, and if somebody gives you this is the angle of, this is the velocity V naught and this is alpha, then how the formula will look like? What will be range, what will be time of flight, and all those things. See, here there is slight mathematical manipulation. See, we took alpha, angle of projection, with respect to positive x-axis. This is your positive x-axis. So here if I See, here I use this coordinate system: x-axis up the incline, y-axis perpendicular incline. So if I stick to the same coordinate axis, x up the incline and y perpendicular to the incline, then according to these formulae, this should be an angle of projection in that case, if I stick to these kind of things. So this is what? This is pi minus alpha. So you just replace everywhere alpha by pi minus alpha. Look at the answer for this. See, alpha is the angle of projection, with alpha is measured with this down the inclined line, but in this formula this alpha was measured with respect to the direction which was positive x-axis. If I take positive x-axis like this, angle of projection will be pi minus alpha in that case, if I stick to this formula. So you will get the formula for down the incline. You just replace alpha with pi minus alpha over here. That will give you the answer. So if I replace alpha with pi minus alpha, this formula is going to remain same. This formula is going to remain same. There will be difference over here. If I replace alpha with pi minus alpha, this will be V0 sine, and this is going to be what? 2 pi minus 2 alpha g cos theta, 2 V0 square sin theta. Sin pi minus alpha is same as sin alpha, so that will come as V0 square sin 2 alpha by g cos theta, 2 V0 sin theta. Do you understand why we are getting negative? Because now the range is this, which is negative x direction, right? Negative x direction. So we can make it positive and get the magnitude of range. You understand why it is negative? See, when range was this, you got positive. When range is this, you got negative, because it is on the negative x-axis. So you can just make it positive and get the magnitude of range. So your range is going to be this. Only difference you will find is in the formula of range. So you don't have to solve separately. Just remember this formula, and that is your range. Everything will remain same. Y max will remain same. Time of flight is going to remain same. Only difference will be just make it positive. That will give you the formula of range also. Alright, I hope you get it. Okay, let's do one question on this. Let's see this question. A man standing on a hilltop projects a stone horizontally with a velocity v0 as shown. Taking the coordinate system like this, find the coordinate of the point where the stone is going to hit the surface. See, this is again the projectile where the body is projected down the incline. We are projecting down the incline. This is going to be theta. So your alpha is theta now, and this is going to move like this. And we have to find the coordinate of this point. So we can use the formula of range to get this distance. So formula of range we will be using is this one, this formula. So let's write it over here. The first term is v0 square. I don't remember exactly. I have to see it and then copy it. If you remember it, it's good. If you don't remember it, then you have to solve it again. So you can do it here itself. The range is v0 square. That will be coming simply from the formula of the first one is simply the formula of range for the projectile on plane surface, g cos theta. That's the first term. Second term is going to be 2 v0 square sin theta sin square alpha. 2 v0 square sine theta sine square alpha upon g cos square theta. Okay, so let's make use of this formula. We'll get this R. So here alpha is same as theta. Since you are thrown in horizontal direction, so this theta and this theta is going to be same. So alpha is same as theta, so this will be replaced with sine 2 theta, and sine 2 theta is 2 sine theta cos theta, g cos theta, and 2 E naught square sine theta sine square theta and g cos square theta. Is it not? Okay, so that will simply give you, okay, this is the answer, this is the R basically, this is the R. Of previous you can take something common also. This will be 2 E naught square and sine theta can be taken common upon g can be taken common, g cos theta can be taken, cos theta will cancel out, right? Cos theta and cos theta will cancel out. So 2 E naught square sine theta by g, okay, this is first term, and then you have what here, tan square theta, which is equal to 2 E naught square sine theta sec square theta by g. Okay, this is going to be the range, and once you got this, you can get the coordinate also. The x coordinate is going to be, and just take this distance, and this distance will be r cos theta, that will be 2 E naught square sine theta sec theta by g, which is same as 2 E naught square tan theta by g, and y coordinate will be r sine theta minus r sine theta, which is 2 E naught square sine square theta sec square theta, which will give you tan square theta minus sine upon g. That will be x and y coordinate. That is x and y coordinate. Okay, so we can use this formula. Just remember this formula. Okay, thank you very much.